I'm Ben Parees. I lead the developer experience team on OpenShift from Red Hat, and so we contribute the S2I project as well as the build functionality on OpenShift. And this is Matt Moore. Is your mic off?
Testing. Yeah, so I'm Matt Moore. I work in container tools at Google, and I sort of have my fingers in a lot of pies, including container builds, container registry, and so on.
Just a quick poll, how many people were at our session, the intro session yesterday? Good, we didn't scare too many people away. All right, so today we're going to be following up on that and talking about how to take those technologies that we discussed yesterday, all the different build tools, how do you build images, and talk about what it would mean to bring them to a Kubernetes cluster. So we're going to go through kind of what are the options today that exist, and then we're going to talk through some proposals about where we see the space going in the future, and then open the floor for discussion and get some thoughts from you guys as well about what you think you'd like to see in build capabilities on Kubernetes. So today, one of your options, and this is probably what most people are doing today, if you're even doing image builds on cluster at all, a lot of people are probably doing their image builds off the cluster, but if you're doing it on cluster, then you're probably running a privileged pod, which if you watched Liz's session this morning, you know why not to do that. But you're running a privileged pod, you're mounting the Docker socket into that privileged pod, and then you're invoking Docker build with your Dockerfile. You're also obviously mounting all your build content into that pod or injecting it. And then you push the resulting image up to your registry. And ta-da, you have built an image in a very insecure way. So what's good? Well, you can do that today on any cluster. Doesn't require anything you don't have out of the box, as long as you have a Docker daemon available. So with things like Cryo, you might be starting to run clusters where you don't have a Docker daemon on your host nodes, and so that's an immediate limitation as far as using this approach. And you get really great layer sharing and reuse. Again, we talked some about this yesterday, but because you're building effectively on the host machine, all the layers that you built during that Docker build process are going to be in that local storage. And so if you come back later and do another build on that machine, all those layers are available in the cache and get reused. So you get good build performance as a result of that. Bad part is see Liz's discussion this morning. I think she covered everything that I was going to say about this, but you're opening up your host essentially to anybody who can create those pods to do anything they want on that host machine. So if you're running a development cluster or you trust everybody who's running on that cluster, both trust them not to be malicious and trust them not to do something dumb, then it's okay. But if you want to do a multi-tenant environment, then it's not going to work for you. And it also means that developers need to learn Dockerfile's not necessarily the worst thing in the world, but again, from our discussion yesterday, if you want to insulate your developers from Dockerfiles, let them just work in source code, then this approach doesn't give you that abstraction. So the other option today, and I apologize if this feels a little bit like a product plug, but it's going to lead to where do we go as a community in this space. So there is the OpenShift build API. So you have to be running an OpenShift cluster, but it is an API resource defined according to the Kubernetes spec that lets you define a build you want to run on the cluster. And there is a controller that recognizes you've created this build API object and creates a privileged pod on the user's behalf, but that the user does not actually have direct control over. So the operations that are performed within that privileged pod are completely controlled by the build logic, nothing that the user is able to control. So it's going to be safe logic that's either going to do the S2I build or a Docker build, but without, again, user injection of their own logic in that privileged environment. So it's nice that it's a first-class API for connecting the builds, so you can use your client commands to query the list of builds. They show up as resources just like pods or deployments or anything else. You can create the builds, you can watch the state of them, you can view their logs. All that looks just like working with any other Kubernetes resource. And users don't get access to the privileged pods. They don't need access to the privileged pods. They also don't get access to the Docker daemon. And if you're using S2I builds, you don't even need a Dockerfile, so you've abstracted that away. And because it is effectively still doing that Docker build on host, you're getting that layer reuse as long as your build lands on the same node again or a future build. What's bad, it's still using privileged pods. So if there is a vulnerability, it could be an exposure for the cluster. And it is an OpenShift specific feature. The API and the controller that make all of this work do not exist on Kubernetes today. And then it also still requires the Docker daemon. Both S2I and the Docker build approach are interacting with the Docker daemon. So if you're trying to use cryo and you want to get rid of the Docker daemon entirely, you can't. You can move to cryo, but you still have to also have a Docker daemon running on your hosts in parallel. So what does this API look like? Again, just sort of setting the table for the future of a build API in general. We provide an input for your Git repository for your source code. You can provide input from other images. So if you have an image that contains some dependent jars or some drivers, we can pull down that image, extract the content from that, and provide it as another input that the build will consume. Secrets, Kubernetes secrets, can be provided as content. So if you have a secret that you need to access a Maven repository or something, you can make that available to your build through the Kubernetes secrets API. You can provide your own environment variables for proxy settings or configuration inputs. And then you can also do secrets for accessing the inputs. So there's secrets that are inputs to the build itself, and there are secrets for cloning your source. So if you have a specific secret to access your Git repository or a secret to pull down one of the images that you're getting content from, you can supply those as well. When these builds get scheduled, we offer serial and parallel scheduling. By default, it's serial. If you define what we call a build config, and then each time you trigger that build, you'll get a build object. We'll run one at a time until they're all done, or you can run them all in parallel. And you can configure the resources, because these things all run in pods, how many resources, just like any other pod, you want that build to be able to consume. And you can trigger your builds via webhooks, both GitHub, GitLab, et cetera. Webhooks, also a generic webhook. And also on image change. So if your base image that your build is going off of changes, we can automatically trigger a build. So if there's a security vulnerability in RHEL and your image is based on RHEL, you get the new RHEL image, we'll rebuild your application image on top of it without you looking at anything. And same thing if you're getting content from other images, that can also trigger your build to rerun. And then finally, where do you want to push your application image when you're done? So your output target, any registry you want to push to, and if necessary, a secret that enables you to push there. Wouldn't be a Kubernetes presentation without some YAML. So here is an example of the build config API spec'd out. And you can basically just see the various inputs that I discussed. There is more than what is seen here, but you can see here we've got the run policy as serial. We've got a GitHub trigger so that when your GitHub repository changes, we will trigger a build here. We also have an image change trigger so that if the base image changes, we'll run a build. We've got our Git source repository, myapp/ruby. We also have a Git ref, so we're actually going to build a specific branch of that repository. We've got our Git source secret so that we can actually clone that repo in case it's private. And then as far as on the other side, we've got the strategy. So this is where we decide, are we using S2I? Are we using Docker? Are we going to use something else? And so here we're using the S2I strategy, source strategy. And we're saying the builder image is going to be this Ruby 2.4. And you see it says image stream tag. That's an abstraction that OpenShift wraps around access to images. But basically, you can think of, you're saying, I want to use the Ruby version 2.4 tag. And then lastly, we have the output target, again, wrapped with an image stream, but basically saying, this is the image that we're going to push out when this build finishes. So that's the OpenShift build API. Another technology that I just recently became familiar with is and I'm not affiliated with this project, but is the Container Builder Interface project. And this is one of the first attempts to define a CRD for builds on Kubernetes. So it attempts to actually abstract a few of the different build technologies. It lets you define a build configuration in a custom resource and provides wrappers and plugins so that you can do a Docker-based build, build kit, builda, or Conoco. I think those are the 4 it covers today, but it's intended to be a very pluggable system where if you have other ways to build images in the future, it would be able to wrap those as well. Again, runs those on the Kubernetes cluster. It's got all the same security problems as I mentioned at the beginning in the sense of needing access to the Docker socket. And then as far as its inputs, you can provide the context for your Docker build from either a Git repo or a Kubernetes config map.
So another CRD worth calling out that I know some projects are using for build is the AgroProj workflow CRD. This example is largely lifted from one of the sample YAMLs in their repo, but you can see that it's basically launching a Docker and Docker sidecar, and there's a little script in here that actually will run a Dockerfile-based build against it. You know, again, this is not necessarily purpose-built for builds. I think it's intended to be sort of a broad workflow solution, but build is you know, one of the types of workloads people have used this for because, you know, it can do Dockerfile builds on cluster. It, you know, certainly in examples like this, it's prone to some of the security problems that, you know, we've been talking about because you can see it's running a privileged sidecar and interacting with that Docker daemon basically directly through this inline shell script here. This is actually not a Kubernetes on cluster build, but what we've been using for Google Container Builder. If you squint and look at it, there are a lot of parallels to it, and today, because of a lot of the security complications with running on cluster builds, we're actually using VM sandboxes to execute each individual build. Part of the reason recently we've been releasing projects like Conoco is to try and move in a direction where you know, these individual steps, which are actually containers that run over some build context, can be made more secure because the API as it exists today is basically giving you the daemon socket from the host and saying, go to town, right? Do your, whatever you do normally, Docker build, Docker push, and whatnot, because we've sort of given up and said, okay, well, the container boundary is not secure. If we need to hand out a Docker daemon socket, you know, we need to assume the user owns the host. And I've played around with it, and it's actually really easy to do the kinds of things Liz does in her demo. But what's really nice about this model is you can plug virtually any builder you want into it, right? You can build and publish a Docker image either publicly or to GCR, and the VM is authenticated with your project that would host the image, and so you can pull down the builder container and execute it in the build context to do nearly arbitrary things. But we would like to move towards a model where we model some of the privileged aspects like Kubernetes does today and can block some of the privileged access, which really the one use case I can think of where we mainly use it today is Dockerfile builds that go through the Docker daemon. And so it seems silly to have this privileged exception for just that one use case. And so with things like you know, Conoco, which we talked about yesterday, it would be great to try and replace that and move to a world where we could run these in an unprivileged setting. And it would be great if we could do that on cluster and shed this VM overhead.
Go ahead.
No. Okay. So, you know, we talked about a bunch of methods. I don't want to claim this as exhaustive, but, you know, one of the things sort of squinting and looking at this, a lot of them feel like they have common elements emerging, right? You know, all of them define some sort of source. You know, Git seems to be pretty popular. One or more steps on sort of how to build that source context, and I think a relatively common pattern is expressing that how in terms of sort of a builder container abstraction. And then oftentimes volumes are useful. I didn't show it on the container builder one. It really, because it's not Kubernetes, you don't have all of those options, so it gives you basically empty dirt. But having access to powerful volumes is actually really interesting. And then, modeling outputs and authentication with resources that are, like source and whatnot are all sort of part of this, right?
I think that might be. Yeah, so what we are hoping to have a discussion about here then is, with what we've seen the landscape come up with so far, and we're starting to see more in the community around these tools, what are your experiences with what you're doing with builds? What do you see in these APIs that's good? What do you see maybe that's bad or missing? We think, as Matt just said, input content is certainly a key part of any API. Pushing the image seems like it's going to be a key part. And the mechanism itself, between yesterday and today, we've covered a lot of different techniques for building images, both Dockerfile-based ones that aren't based on Dockerfile, ones that are based on Docker daemons, ones that aren't based on Docker daemons. Seems likely that we're not going to pick one of those. So probably kind of like the direction the CBI interface is going, and to some extent the OpenShift API is, probably needs to be a pluggable system as well, is at least what we are thinking. So questions or experience that you'd like to share with what you've done building images, either off cluster or on cluster, or directions you're thinking about going?
Hi, I'm Akihiro Suda. I'm the author of the CBI. Thank you for mentioning my work.
Great.
And this is not a question, and just explanation. CBI currently only supports Dockerfile-based builders, but I'm also planning to implement other languages such as Bazel or Source2Image or Google's cloudbuild.yml or anything. So maybe if we can add many languages to CBI interface, maybe we can use CBI as a start point for your proposal.
Cool. Yeah.
I guess it's a little unfair, but because you wouldn't have known this before you wrote the slides, but do you think that the gvisor stuff that was released this week from Google around having sandbox kernels, actually restricting that what that Docker key and kernel can actually do, will actually go some way towards solving those security issues that we've been talking about earlier?
So I'll give the short answer, and then I'll let Matt give the long answer. So yeah, I think it can. I have only read through the blog post on it, but it definitely seems like an exciting technology that would make things like, today there are build systems that spin up a VM so that they can do builds on cluster or effectively on cluster in a safe way. And of course they lose the caching reuse, but they get that security. And the idea of a lightweight way to do that sounds awesome. And yeah, so I think as we see how that project evolves, there's definitely a place for it.
I knew about it. Yes, we've certainly thought about it. As I mentioned yesterday, one of the, I think, really interesting things about gvisor, and one of the considerations when we were thinking about Kaneko was running it in that context. And so, if you wanted to, so one of the interesting things from this morning, and from some of the examples, is a typical way of getting access to the daemon socket is to use the host path to access the host's Unix socket that you use to speak to the Docker daemon. As Ben pointed out, if you're using something like gvisor to do isolation on your cluster, that might not be there. CRIO is the same way, right? So having the capacity to do these in a daemonless way with something like Conoco, Builda, IMG potentially, are interesting. I don't know what the current limits are on gvisor in terms of running that set of things under it but it's one of the reasons that we pursued Conoco is to run it in contexts like that, to get Dockerfile builds in contexts where there isn't a daemon.
Hi. So my question is, you mentioned that you would like to roll the VMs out, exclude them from the picture because of the overhead, but maybe that's not what's always preferable. In some cases, the users may want the isolation that the VMs provide, and there are several projects that support running VMs on Kubernetes clusters, including Red Hat's KubeVirt and Kata containers and Vertlet project that I'm working on. The latter one just makes it possible to run usual VM images as if they were pods. And maybe will something be considered along the lines of using some of those projects to provide the isolation that may be needed by some users?
So I don't know that the sentiment was necessarily that using VMs as the isolation technology at the pod level was the problem. I think that certain systems use sort of single-use VMs to isolate the Docker daemon that is, or the container runtime that's performing the build. And I think some of the patterns we've seen are problematic, even in those environments, right? Because if you're using something like Kata containers, which runs a lightweight VM to isolate your pod, that your pod's reaching out to the host and interacting with a privileged process on the host, you might as well not have put that pod in a Kata container to start, right? Because you now own the host pretty much. Does that answer your question?
What I was meaning, running a Docker daemon that performs the build itself inside a VM. That's so. Yeah.
So you're talking about like in the example where you launch something like a Docker and Docker sidecar, launch that in a Kata container as a sidecar and do the build against that. I think that's, I don't know. It's certainly a possibility. I don't know who's tried it, but
I think it's a possibility. What I've seen so far from at least just watching the community, there seems to be a lot more interest in finding a way to do unprivileged Docker builds through things like Conoco. So, which is just going to be lighter weight than having to spin up a VM each time. So, is it a possibility? Certainly, it gives you great isolation, and I think it's got a lot of benefits there. But if we can get to the point of actually being able to do unprivileged Docker builds first, I think that's preferable from a lightweight efficiency perspective. Yeah.
If you were looking closely to the example that spun up the Docker and Docker sidecar had like a little loop where it was waiting for the Docker daemon to be ready too, which I thought was sort of funny.
I think this man here had a question.
Hi. I just one small question about this Source2I build. Does this OpenShift internal registry required for this Source2Image builds?
Sorry, is the OpenShift
internal registry which comes with OpenShift, does it require to build Source2Image?
No, so Source2Image needs basically, I'll see if I can go through it as 4 things. It needs a Docker socket because it has to be able to launch containers. It needs the builder image and it can pull that build image from any registry. It doesn't, I mean, if you're running on OpenShift, it's probably coming from the internal registry, but it doesn't have to. And then it needs your source code from somewhere, and then it needs somewhere to push the resulting image, which again, on OpenShift will probably be your internal registry, but it does not have to be, no. You should also say that there's a command line version. Yeah, so, and there is also a command line version of S2I if you just want to build on your machine where you don't even have OpenShift. You just do S2I build, tell us your source repo, your builder image, and the output image. It doesn't push it anywhere, it just builds it locally, and then you can Docker push it yourself.
In the spirit of composability, I'm kind of surprised here, but this focus on source, right? There are lots of build pipelines that already take source and produce binaries. Seems to me the remaining step is to take the binaries and produce the image.
I think I think in that case, I think what a lot of these models do is they have a source that is a binary input. I mean, one of the options that, for instance, Container Builder supports is getting the source context from Google Cloud Storage and versus a Git repo. I know that OpenShift supports a lot.
Yeah, I think that's a great point. And the image inputs that I referred to earlier in the build API, that's sort of that concept with the idea of maybe you earlier built some source into a set of jars that you baked into an image, and now you're doing another build where you're going to just take those jars out and put them into a runtime image that's lightweight. So that's certainly one way. And source also probably just an overused term. It really is build inputs frequently get source, not necessarily, yeah.
Could you quickly summarize the reasons why we do need the Docker daemon besides the run statement? If we want to do something like that.
You don't.
Yeah, okay. So if I don't have run...
You said quickly.
Just go for build. Thanks. So if I don't have run statements and I just want to copy my Go binary into the image, I'm good.
So this isn't all you, Matt.
Yeah, I mean, if you don't have run statements in your Dockerfile, they started growing the Dockerfile syntax again, so this may be dated. But basically, every directive in it amounts to things like add and copy, which will modify the file system, and pretty much everything else is some sort of metadata change, exposing ports, declaring volumes, the user, etc. So if you know how to use tar, you can construct the file system elements, and then the rest is a little bit of JSON manipulation. There's a variety of libraries that can do this, and so run makes everything trickier because run is executed by, sorry, there's a weird echo over there. Run is executed by activating the container up to that point, entering it, executing that command, and then snapshotting it, right? So if you don't have run, you don't need to launch and snapshot containers, and so you can do it without a Docker daemon.
But don't we have the ability with whatever container runtime we're using to launch the container, execute a step, and then snapshot it without Docker doing it for us?
Who says we have a container runtime? So one of the things you can do if you construct things this way is effectively from a Chromebook or OS X not running a VM in order to run a Docker daemon is effectively cross-compile your Go binary and slap it on the image, right? Because you're not activating the container, you don't need to do that. It actually makes situations like producing fat images from a single environment with a single tool tractable because...
My concern is not the run, right? I'm surprised. Why is run a problem? Why do we need a Docker daemon to do a run?
You need a container, an isolated container to do the run.
We're in the business of running containers.
We're in the business of running containers typically on orchestrators, right? I think 3 of the things we talked about yesterday were Builda, IMG, and Conoco. None of those use a daemon. Builda and IMG are effectively activating containers, I think, more or less directly via runc. Please correct me. And Conoco expects some sort of orchestrator to put it in an empty container, and then it basically emulates the Dockerfile evaluation by downloading the file system contents, run by executing the command in that context, and then manually snapshotting it itself. Yes, I think to execute run, right, like you more or less need some way of running the container because of how it is imperatively built. But doing that through the Docker daemon traditionally means overexposing yourself to get at that sort of limited functionality. So
I understand that.
I think there's another,
Run it some other way.
yeah, so there's another aspect to this, which is in an ideal world, Kubernetes is already perfectly capable of running containers for you, right? Why are we jumping through all these hoops to run a container in a safe way when, in theory, Kubernetes is already running containers safely, right? The technical obstacle to that today is, yes, I could start up a Kubernetes container from my base image, and I could exec in and run all my Dockerfile commands. There's no way to commit that container.
or push it.
Or push it, sure. So that's kind of the blocker to a build system based on that. If there were an API that allowed you to commit a running Kubernetes pod and get that image ID and push that image, then that would be another approach to this, but that's not a possibility today.
And you couldn't tweak the metadata, right? Kubernetes will start it. It may start it with some metadata, but that I don't think would be committed to the final image.
Yeah, you would actually need a Kubernetes API that says, commit this pod, and by the way, also tweak all this metadata about it.
So my question is more for the audience. So I'm curious how many people think Dockerfile-based builds is important for their future usage? Like, is it a part of the experience what they already have in tech debt? Is it critical, or meaning if you didn't have Docker files in your life?
And had exactly the same question I had.
Yeah.
I don't care what format.
Sample size of 1.
Scripts or whatever, as long as it's declarative and easy to understand how you do it.
I'd argue run's not declarative, but.
So I'm from a service provider, so I've got customers who are going to want Docker files as long as there are people that want Docker files.
Me too. That's part of the reason for projects like Builda, Conoco, right? Like we recognize I don't want to speak for you guys, but we recognize the customer need, and this also goes to why GCB, the container builder, was basically like, well, we got to support Docker files, and if we've got to support Docker files until something better comes along, we have to do things a certain way. And now that some of those better things are coming along, we want to consider ways of reevaluating that. And so I absolutely recognize the need for it. But I'm personally very interested in pursuing better ways of building images that, don't need that, and advocating for better ways that don't need that. And I'm really happy that approaches have emerged that make Dockerfile-based builds better, but I also, I have a higher bar than that. I don't know.
I think we're actually out of time.
Yeah. We were encouraged to
1 more minute.
tell you guys to jump us in the hall if we run out of time.
Yeah.
I would just say that I think that when it comes to large platforms where you're running Kubernetes or OpenShift, really at that end, you don't care what's building it, right? As long as it's compliant and it works and everything's great. So the best and most efficient way, whether that's Docker today or some other technology like Build It Tomorrow is one thing. It's really only becomes, a Dockerfile only becomes something that might be important to developers on laptops who are learning about this technology and stuff like that. But once you get into a scalable environment, it really doesn't matter as long as the containers are compliant and run in an efficient way and are built in an efficient way.
I think we're out of time.
Yeah, we'll wrap it up.
I was gonna,
I'll certainly be around. I don't know if
jump
you have
into a
anywhere to run
spiel,
to,
but-
but thank you.
Thank you, everyone.